Welcome everybody. A little bit about myself and why I'm doing this. First of all, I will have to make some full disclosure at the beginning, is that I am a little bit of an R fanboy. So I have a very, very favorable view of what R can do for us, and I think it's somewhat a little bit underappreciated. The goal of this webinar is to introduce you to the world of R. Now, my inner geek wants to delve deep into all the arcane, cool stuff in R, but we're not going to do that. What we're going to do is try to give a lay of the land, understand what R is, what it's intended for, what its capabilities are, and how R is evolving to meet the demands that we're seeing in data analytics, business intelligence, and other related areas. So for myself, my professional training began in university. Academically, I was trained as a mathematician, statistician, cognitive scientist, and I started doing a lot of data analytics actually back in the engineering community, where we're developing statistical models for transportation engineering and other statistical models for physicists. I was the mathematician, so I got to be the guy to help work with all the equations. After that, I went into working with market research, developing again numbers of statistical models and doing an analysis. And this was at the time in which the only things available to us were really SAS and SPSS. So we had a lot of challenges in actually building and computing our models. And over the years, I've done a number of other sorts of types of work that have required various kinds of statistical modeling and building models, doing analytics, including data mining, machine learning, and other sorts of topics. When I first encountered R, my first reaction was, where have you been all my life? Because what it does is it provides a set of automation tools from the point of view of a data scientist, which I really started to appreciate. So what we're going to do today is go through an introduction to the R Studio ecosystem. So we're going to talk about R itself, or we're not going to get deep into all how you program R or anything like that. Just an idea of what the R language is. Some of its capabilities that are built into it, data manipulation and visualization. I want to talk about the R CRAN network, which is one of the features of R which makes it incredibly powerful. Then we're going to look a little bit at how R is becoming one of the integral parts of the revolution or rise of machine learning and big data. Then finally, we'll take a little look at whither R, where and whence R, where we're going, and what's the likely future of R. So we'll try and cover all of those sorts of things as well. Now, the first thing I'll mention here is this notion of the R ecosystem. R is not just a programming language, which is why it is so nice working in the data visualization and data analytics world. And one of the main reasons why R is popular with a lot of data scientists is because when we're working with large amounts of data, we often want to build our analytics on the axiom of know thy data. Before you start analyzing petabytes or terabytes of data, you want to get a good sense of what your data is. You want to profile your data. You want to look at the data quality. And you also want to experiment with different ways of manipulating the data using some kind of sample of your data to figure out what kind of analysis is going to work for what you want to do. That's really where R excels. It is a language where data scientists can experiment with their data, profile their data, understand the quality of the data, write scripts that manipulate the data, and with your colleagues, share those scripts so that when you come up with analytical models, you can show people exactly, or your peers exactly, how those models were created, and they can reproduce those results. So this is a very much of a tool oriented towards data scientists, as opposed to something like Python, which is a general programming language which also does data analytics as well. R is not intended to be a general programming language. It is specialized for data analysis. Now, it contains a number of things. It contains a powerful scripting language called R. And R is interesting because a lot of the built-in functions and packages we're going to look at themselves are actually written in C and Fortran and C++, so they tend to have very, very good performance characteristics. R is the scripting language that kind of binds everything all together that we kind of do our experimenting in. So R attempts to achieve a balance between performance and convenience. It supports high-level array and matrix operations for modeling. It's not quite as good as MATLAB or Octave in doing this, but it does have these high-level array and matrix operations, so we don't have to write a lot of low-level code, which is really nice. It also has very effective data handling and storage capabilities. It introduced data frames, which has been a standard tool adopted in other approaches. Pandas in Python, for example, as a package, has extended the notion of data frames into the Python world. And additionally, we find things like Spark, Apache Spark, and working with big data also have adopted the whole data frames approach. So it has a lot of very convenient tools for manipulating data, moving data in and out, organizing data, and also has a number of built-in tools for data analysis, which allow you to do very, very quick prototyping and analytics of the data. And then it's got this large library of special purpose packages. And we're going to take a look at those as we go through. R is also what we call a language binding. In other words, if you're writing code to manipulate machine learning models in something like TensorFlow, or big data in Apache Spark, you can write your code that in R, as well as other programming language, to actually be able to use those toolkits. So it's what we call a language binding. So in other words, you can actually access those tools very comfortably in R. Now, RStudio is a desktop environment, which I've got, of course, set up here. Here's our lovely RStudio, and we're going to play around a little bit with it and do some of the demos that are in here as well. So we'll have some experimentation with that. It's intended to be a workbench for data analytics, so you can actually do some of your coding. So for example, there's a lovely R interpreter here, which gives us a basic kind of functionality. Whoops, there we go. I guess I should be actually in there. It gives us a very, very interesting kinds of functionality. So we can do a number of things with R as a basic programming language on the fly in this interpreted environment. This is similar that we would do with something like Python or some of the other interpreted languages. Again, this is intended for us to be able to do this kind of interactive analytics, very much designed for us. So we're going to work with the RStudio as we go through to see some of the features of R. Okay. All right, so that was just the demo we just did. Okay, so where does R come from? It was actually, has a long history. It's not just something that appeared one day. It started in 1976 at Bell Labs where they were developing a statistical package called S. And in about 1992, it caught the attention of Ross Haka and Robert Gentleman in the University of Auckland in New Zealand, who spent a couple of years developing a open source variant or dialect of S called R, which was both a play on the name S and also the first letters of their first names. And they open sourced this and introduced it to the world in 1995, and it's currently being maintained by what's called the R development core teams. This is a real widely distributed open source project. I think Gentleman is still on the R team, but it is heavily supported by data scientists, particularly in the academic community around the world. And like I said, it's a dialect of S, so most S applications will run in it. S is a proprietary language. R is open source. But again, I come back to the idea that part of the architecture of R is to allow an easy scripting interface, but have the heavy lifting done by compiled C, Fortran, and C++ libraries to optimize for speed. Now, there's also parts of R that are actually written in R as well. When we take a look at where R is in the programming space, when we start to look at data scientists, now if you put R up against all the programming languages that are out there, It doesn't look very. It doesn't make the. It doesn't really cut. I think even now cut the top 20 because you've got JavaScript and C and Go and Rust and C++ and all of the Java and all of the other ones out there. But when we focus the question on, so if you're doing data analysis and data mining, what is the language is your go-to language? And you can see here that R is actually is the most popular one for data analysis. As Python and R are pretty much nowadays sort of neck and neck. They are the two go-to choices, and most of these other ones tend to fall apart. Python's actually increased a little bit since with this survey was done. So when we actually look at popularity of R and we confine it to the data analytics world, we tend to see that R definitely is maintaining its own. This is a log scale, so it's giving us a little bit of a linear estimate of some exponential growth, and you can see that SPSS is trending down a little bit as we get into 2015, and R is continuing to grow along with some of the other tools itself. And this is in terms of the number of scholarly articles. Now, one of the reasons why those scholarly articles are citing R is, again, because it's the ability to share reproducible results, which is actually quite important when we're proposing various kinds of statistical analysis and modeling. Okay, so let's take a look at the R language itself. It has some fairly standard programming functionality. We're not going to start learning about programming in R, and I'm just going to do a couple of, I've put some code snippets in here so that I don't have to type them in. So R has fairly standard types of functionality. So I can define a function in R, for example, and I can use my function there. So I'm creating a power function. If you know programming, this looks like a fairly standard programming language. And so let's actually now use that function. I don't know if I've done it correctly. Whoops, cannot function pow. There we go. Okay, so there we go. That should be, oh, I see what the problem was. Okay, well, oops, I did that. Kind of pasted that wrong anyway. What we can do is we can define functions like that. We'll take a look at a couple of others as we go through here. Let me take a look here. There we go. There's an example. Actually, let's just go back and fix this one up here. Oops, sorry. This is always nerve-wracking when you're trying to do this with people watching. There we go. That's what I was doing. All right, I just didn't notice I'd missed that little thing there. All right, so it's fairly standard functionality again, and this one just gives you a sample of the fact that anybody who knows a standard programming language or various kinds of functional things, if, else, then, statements, loops, all of that kind of stuff is supported here. So now we can do here check 0, and works exactly the same as we would expect. So R provides a standard programming interface, which is nice because we can get people who know a programming language into using it very well. We also have various kinds of vector matrix operations. We can just take a look at just what we mean by that. Let me go and pull that up here. So, for example, we can pull a lovely little matrix here. I'll just pull one up. And we can print out our matrix. And very easy to define matrices. And it also supports a very nice interface into doing various kinds of operations. So, for example, we can do element by element things like subtraction. We can also do various sorts of things like matrix multiplication. And again, I'm not going to go into it, but what I did want to just show here is that we have a fairly standard programming model, plus we have the kind of facility for working with matrices and arrays that's actually very, makes it very easy to work with. Again, when you're doing data prototyping and analysis and you're working with various kinds of algorithms, but just pull one off the top here, like gradient descent. This is the kind of thing that works out very, very well. So, so R has that. Now R Studio is this interactive environment. We can also write R code as scripts and run them the same way we run Python scripts. As a matter of fact, you can see what I've got here in this RStudio is that I've actually gone and I've got all of these, the code I was just pasting, writing and cutting and pasting. I could have also run this as a script at the command line. So I can run it interactively, or I can run it as a script. So we have that sort of environment, just basically showing that. The other thing about R that a lot of people don't realize, it has a lot of very advanced programming features, which become very powerful. It supports functional programming. It supports 3 different kinds of object-oriented programming with 3 different object-oriented programming models. It has an extensive library for memory management, performance, and profiling, so that we can actually do various kinds of analytics on the algorithms that we're using, seeing how they're performing, performance bottlenecks, what's going on inside of our analysis. Unfortunately, a lot of people don't really exploit the power of these features of R, but they do make for some very, very interesting. They do make for some very, very interesting capabilities when we're working with very sophisticated data analysis. And I'm not going to for example, here's just an example of some functional programming in R, in which we're basically going to take a function as input and return a vector as an output. So we're basically a randomized function that, given some function like mean or sum, is going to return some kind of output. And to just see that that actually works, we'll pop this in here. And just to, okay, so what we're doing here is, whoops, randomize it as you spell it correctly there. And so we've just taken a random array of vectors and we've applied the mean function and returned a mean. Okay, so the idea here is, from a programming perspective, and this is really what we just wanted to mention about this, is that R is a sophisticated programming language. And we don't actually need to do a lot of sophisticated programming, but it has that capabilities. So it is a well thought out environment. Now, most of us who use R are really interested in the use of R for profiling and understanding our data. So there's a lot of very there is an extensive library of built-in functions that allow us to do various kinds of analysis. So, for example, let's pull up a little example here. So, for example, what we can do here is I can pull up a various kinds of probability distributions. So in this particular case, what I'm going to do is I'm going to pull up a probability distribution. So let's take a look at Y. So what I've done is I've created a normal distribution that's been normalized for Y. So I'm sorry, that's been normalized, and I stored that in Y. But I can do a number of things with that. For example, I can look at the mean of Y, and I can look at the standard deviation of Y, again, without any particular let me just look at some medians. So I can perform various kinds of normal results on it, or normal in the sense of the kinds of things that I would do. But I can also pull up things like summary statistics of that distribution. So in a few lines of code, I'm able to generate a normal distribution and pull up some statistics. So that's just to demonstrate that we've got these lovely, very powerful built-in functions that allow us to do various kinds of statistical profiling very quickly. But that's not exactly where the power of R comes in, because you want to combine that then with the ability to, right here, hold on here, I think, there we go. You want to be able to combine that with your ability to do various kinds of plotting. So this plot function built right into core language allows you to take various kinds of statistical results and plot them so that they're quite visual. This is the important part of data visualization, being able to actually visualize what's going on in your data. So there's just a quick example there. You can perform various other kinds of plotting. For example, we're just going to plot a standard sine wave here. And so one of the important parts about any kind of working with data is being able to understand your data, like I said, visualization. So where R has a particularly powerful appeal is that the statistical manipulation is just a core part of the language, as is the plotting of the statistical results. There are some other things that we can do. The demos here. There we go. So R also comes with a large number of demos to illustrate. I'm going to just use a couple of these to show how powerful, in fact, this particular approach is. And I want to make sure I've got, there we go. We're on that page. So I'm going to expand this up a little bit, and I'm going to do the demo for example image, to show you this kind of images that are capable of being developed for visualization. It always depends on my being able to spell correctly too. Image, not images, there we go. And if we look over here at the, oops, sorry, I just want to move this thing over here. All right. Okay, let's try this again here. There we go. Okay, so now if I look at the various kinds of images we can get, there are some various kinds of heat maps. If you notice down in the corner there, there are various parameters we can tune with all of our image to get various kinds of things which allow us to visualize. These are all topographical, for example. And also showing various kinds of heat maps, which are always particularly useful. Another example here is, we'll take a look at plot math. And again, to be able to demonstrate that we also have a lot of lovely rendering sorts of things that we can do, which makes things very, very nice in terms of being able to present results. So, for example, we also have the ability to document and express using the built-in LaTeX features that we have in R. And finally, just the last little demo here. There we go. Oops. Hold on. Okay, there we go. I just want to finish that off here. sorry, my typing. There we go, demo, and that should work. There we go, and just again, a variety of different kinds of plotting mechanisms are also available. Pie charts, various kinds of box plots, graphs, various kinds of visual representations of data. So there are or there is a wide range of capabilities, scatter plots. All of these sorts of things are part of the R language, so it's very easy to get into a quick data analysis in R. Okay, so the idea behind R again is to try to make the use of R. Oh, by the way, a couple of things we'll notice about RStudio is that in RStudio here, I've got a number of different the ability to go and look back in my environment. For example, here's my X that I created before. I have a number of different things. I've got check as the function I created. If I double click on that, it'll actually take me to my function. So there's a number of what we might call convenience features for people who are working in this environment. So the RStudio as a desktop provides a lovely, highly user-friendly interface into being able to build our programs and analysis. For example, I go back and look at POW. I can see all of the various kinds of things that I'm currently working on in my environment. So now the final thing I wanted to just talk about in terms of the actual R interface itself is this notion of a data frame. And to do this, I'm going to just take this data frame I've got here. Now, what I've done is I have gone down to the, let me pull this up here. I've gone to the a source for data, and I've been able to pull down this data source, which is income for White House employees and their title for 2010. So this is in a CSV file format. What R allows me to do is to very quickly bring that data into okay. All right, so I'm probably not in the right directory there. Hold on. There we go. I should be in there. All right. Well, anyway, I kind of messed someone up here. Anyway, what I can do is I can pull this data in very quickly into a data frame. And what this data frame allows me to do is to go and work with it in a tabular format, which has got rows and columns. Now I can look at some other data frames here as well. Oops. R comes with a number of data sets. So for example, the data set iris is a data frame containing the some information about various statistics about the various kinds of irises that are out there. And this is the kind of data set that's supplied. There's a whole bunch of them which are supplied, and I think there's things like U.S. auto accidents, voting, a number of different data sets that are supplied by R that you can download and experiment with. So this is an example of a data frame. Down here on the left, I've got the row entry, the number of rows across the top. I've got the columns, and I can do various kinds of analysis on my data frame. I can do, for example, a summary analysis, and it works on various rows and various columns. So again, what data frames do is allow for a very, very efficient importing of data from CSV and other kinds of environments that allow me to be able to manipulate and use the capabilities very, very quickly. Sure wonder where that file went to. Okay, so those are the core. Those are the core kind of ideas about what we're going to find in R. So just to summarize at this point, we've got R, very powerful programming language. It's got a lot of its heavy lifting modules written in C, C++, and Fortran for speed and convenience. It's a scripting language that allows you to do various kinds of experimentation. Built into the core language, experimentation like data visualization, data quality, data profiling. It has built into the language very, very powerful standard statistical operations and standard plotting operations, which means that you can basically play with the data in something like RStudio, which has extensive support for working with R in that particular when you're developing some kind of R project. The other thing we want to quickly talk about is what makes R really, really powerful is this CRAN network. Now, CRAN is the let me go and I've got CRAN up here. CRAN is called the Comprehensive R Archive Network. Now, R is like a lot of modern programming language in that it allows for a public repository of specialized packages. Python follows the same model. So does Go, Rust, Ruby with Ruby gems. And the idea here is that because we're working in the data analysis community, people have already developed analytical tools for very specific kinds of data analysis. So if we go into the packages that are supplied here, if we take a look at available packages, there's a package of available packages. And we just take a quick look at the kinds of packages that are available. You'll see there's an incredible range of things from a Bayesian A/B testing, data quality visualization tool for partially accruing data. I'm even just in the A's at this particular point, spatial point patterns analysis. These are contributed generally by people who've developed them for their own projects and realize that they're useful for other people. As you can see, I'm still only in the A's and B's. There's a wide range of packages that are, for example, here's an interesting one. Was that create their block, assign, and diagnose potential interference in randomized experiments. Now that can be a little bit overwhelming, but fortunately, the packages are also organized in task views. What a task view does is it organizes the packages by categories. As you can see here, this makes it a little bit easier to work with. We've got econometrics, environmetrics, meta-analysis, missing data packages, social sciences, robust. If we go into social sciences, it gives you a list of all of the various packages that are included in this particular view. Bayesian meta-analysis, so there's a number of tasks that are associated with this. Let's go into survival, time series. We wind up with a time series analysis package, which gives you the basics of what is what's in this package, what you can do with it, and again, these are all generally very well documented. So, for example, let's take a look at WWN tests. So here's one for hypothesis test for functional time series. It has the README views. Most of these packages come with a reference manual, which describes what's in the package, how it's used, and a number of the other pieces of information regarding the package, which are going to be of use or of interest to anybody who's going to be using this package. So one of the things that makes R so powerful is this extensive repository of highly specialized packages. And you can install these packages actually quite simply. Well, in fact, we'll just do one now just to see how simple this could be. So let's go and grab a package off of the package list, and we'll take a look at a package here. Let's take a look at, let me see, Bayesian optimization. We'll do multigraph. See if we can do that. Now, oops, right here. I always want to make sure I got the syntax right. Hold on here. I did something earlier. I want to make sure I don't try and install the same thing. Okay. And let's do, install the package. What was the package I wanted to install? Let's do multigraph. Now, when I install the multigraph package, it's going to go out to the CRAN repository. Now, the interesting thing about installing the package, it's downloading it, but it's also now going and in some cases is actually going to compile the package down to C code that'll run very, very effectively on my system. So in this particular case, it very successfully installed the two packages, and now all of the functionality of those packages are going to be available to me in this R environment. This is, when we're talking about the power of R, this is the kind of thing that makes R really, really attractive, because I'm not always going to be reinventing the wheel. I'm always going to be able to go and leverage the work of others if it's relevant to what I'm doing. This is pretty much the standard model we find nowadays around the internet when we're working with modern programming languages, modern big data environments, is this notion of repositories, whether it's crates in Rust, packages in Go, gems in Ruby, packages in R. R was one of the first languages to really adopt this model. And it is one of the reasons why R has become very, very popular. Okay, so I'm going to get out of the actual playing with R now and just talk about a couple of other little things before we close up for questions. The first one is that R is what we call a data bind or a language binding to a lot of the very popular machine learning and artificial intelligence tools. One of the most popular toolkits is TensorFlow. And here's an example of R actually interacting with TensorFlow through this language binding in Keras, which is one of the programming interfaces into TensorFlow. In this particular case, this R code is actually going and building a simple neural network in TensorFlow through the Keras interface. So we can now, if we are a data scientist, we don't have to actually go and work with learn a new programming language. If we want to do some kind of machine learning modeling, what we can do is we can access something like TensorFlow directly from an R interface. Here's another example of using TensorFlow, or in RStudio, using TensorFlow to actually build a machine learning model. Where we're actually training our model and utilizing the power of TensorFlow. In the big data world, R is also used as a programming interface to a number of the big data tools. One of the most notable, of course, is Spark. Spark is the tool of choice by a lot of people now for doing various kinds of big data analytics. But you can program Spark in a number of languages like Scala or Python or Java, but our interface is particularly interesting because what it does is allows data analysts to be able to work with the big data capabilities of Spark. Now we're talking about using petabytes of data, exabytes of data, terabytes of data, and being able to, instead of having R being responsible for trying to work with that data directly, being able to talk to Spark and have Spark able to work with that data for R, but the analysis is still being written in the R environment. And here's an example of interacting with Spark through the R Studio interface. So this kind of ability to interact with these other tools is one of the things that's really driving R. Now we're going to be realistic and say that first of all, as far as the future of R goes, R is a niche language. It's not an everyday common ordinary programming language. To compare R to Python is a bit unfair because Python has a wide range of uses. It's a general purpose programming language. So it's going to have a much larger adopted base of languages. However, Python is acquiring a large following for its libraries in data analytics and machine learning. So it is certainly increasing in popularity. So in other words, here's some KD nuggets analytics for data mining. Science and machine learning software. Again, we can see that Python at this particular point is still, in 2018, is still out front, but R maintains a significant share of that, and partly through the fact that it is something that's easier generally for data scientists to use as opposed to computer programmers. One of the things we have noticed is that R seems to have taken a hit in terms of its popularity. And that's partly not so much due to the fact that people don't like R, it's more to the fact that Python has got such an incredible jump in popularity. So a lot of people are actually going with Python instead of R because they are providing somewhat the same functionality. But we still have that main, I'll call it the die-hard core of data scientists who are going to stick with R because, again, it's designed for data analytics. Now, notice in particular what really works nicely for R is that R Studio environment. Now, with the rise of Jupyter notebooks for Python, we have seen similar kinds of things taking place with Python, which is one reason why Python is getting so popular. But if we still look at the popularity on GitHub of number of projects, you'll notice that R is still right up here at the top, along with not just R is right up here at the top, along with the general programming language like JavaScript, C#, Python, Scala, Ruby. So in other words, R is still maintaining a very high profile in terms of analytics. But what about this problem of Java and R? Well, what's actually happening is very interesting. People are starting to say, you know what, R and Python are starting to duplicate what each other is doing. And maybe we've got to start thinking in terms of R and Python as a single unified ecosystem, which allow different kinds of interfaces. So we'll have the same sort of underlying core of functionality, but if you're a data scientist, you can approach that through an R Studio approach. And if you're in a machine learning programming environment, you can approach that through a Python approach. In this particular case, there are already tools. So for example, we can run R code from Python using a Python package called PyPR. And we can also run Python code in R. And so what we're really looking at now is convergence, and we're seeing this as a general trend amongst programming languages, is that we're having this ecosystem of tools, capabilities, and libraries, but we're starting to be able to look at the idea of calling them from multiple languages. So in the future of R, we're going to see R maintain its niche presence among data scientists because of its ease of use in working with data science, particularly, like I said, profiling, data quality, data visualization. but it's going to maintain its popularity, or it's going to maintain its support because of it's also its ability now to integrate with things like machine learning, big data, and it's going to be a kind of environment that is still going to appeal to data scientists. So for example, one of the things we'll notice that if you look at the academic world of people doing research in various kinds of areas involving statistical analysis, R is still way up at the top. And so there's a number of reasons why we're going to continue to see that. Like I said, one of the nice things about R is that it is actually easy to prototype, to script, to play around with the statistics if you're a data scientist. These are very, very appealing features. So we're going to see that continuing to happen in the R world. All right, so that'll bring us to our questions. So if you have any questions, we'll jump onto that. So we've had a very brief overview of R and RStudio. I couldn't find that stupid White House file, but aside from that, what I wanted to do is give you an idea of what R and RStudio are, the capabilities, kind of the general trend and where it fits into it. We couldn't learn to program in R in 40 minutes or so.
We are StarWeaver, education you can bank on. For more information, contact us.